Hi there. Today we're looking at the next special formula for factoring. And this is all about what we call perfect square trinomials. And this might not make sense to you yet, but let's take a look at this example here. So here we do in fact have a trinomial, x squared plus 4x plus 4. Let's try and factor it, okay? So if we're going to factor this, what we're going to look for is the factors of 4 that add up to 4, right? That's what we're looking for here. So the factors of 4 that add up to 4, right? And so we can write down the factors of 4. That's going to be 1 times 4 or 2 times 2. And clearly it's going to be this second set right here because 2 plus 2 equals 4. So those are the numbers we want to use. That means this should be equal to some x plus 2 times x plus 2. And I can condense that because this is the same thing. I can say this is x plus 2 squared, right? And now you kind of see why we call this a perfect square trinomial, because it is a trinomial, but it's the result of a sort of a perfect squared binomial, right? So you take this binomial and you square it and you're going to get this trinomial. Okay, so that's the idea here. Now that's not too hard, and you can always fall back to the standard methods of factoring quadratic expressions, but I want you to notice a pattern because we've done something like this before. We've had, when we were learning how to multiply polynomials, we've looked at when you have some a plus b quantity squared, and we discovered that when you FOIL this out, you get some a squared plus 2ab plus b squared. And so really what we've done here is we've gone the other direction, haven't we, right? We've sort of figured out that if you start with this, then you can get the a plus b quantity squared. And so that's what we're going to use here. It's essentially the special formula, right? You can start out with this and then you're going to get that. And so that's actually what this is here. You just need to be able to recognize the form here. And we're going to talk about how we can recognize that in a little bit. But I want to show you another example here of a perfect square trinomial. And that's where you have x squared minus 4x plus 4. Okay, this is going to be very similar. In fact, we could probably sort of do the same exact thing that we did here. We need the product of the factors to equal 4, but we need to add them to get a negative 4. Okay, and so now, if you remember how we did this, we recognized that to get a negative number, both of these factors must be negative then, right? So negative times negative will equal a positive, but negative plus a negative will give you a negative. Okay, so that's why we do that. So here then we must have something like a negative 1 times a negative 4, or a negative 2 times a negative 2. And clearly, again, it's going to be this second one here. Negative 2 plus negative 2 equals negative 4. So just like before, we can write this as a negative x minus 2 times an x minus 2, and that's the same as x minus 2 squared, okay? Using the same logic as before, we recognize we have looked at expressions of a minus b squared, right? The product, sort of the square of a difference here, right? And we remember this should give us some a squared minus 2ab minus b squared, just like that. And so what we've got is going the other way, we're going to get a formula, right? That'll look something like that. And so this is essentially what we're doing. The key here is to recognize if your quadratic expression actually fits this form or not, right? If you don't recognize that it does and just go through the standard way of solving or factoring a quadratic expression, you're fine, right? You don't need to memorize this, but it can be handy, can save you some time. So let's look at an example here and sort of think about how we can recognize this pattern. Okay, so here what I want to do is I want to sort of write this down, and I want to see, does it meet some form where this is some number squared and this is also a perfect square here? Okay, so x squared is definitely a perfect square. I want to see, is the last term a perfect square? Yeah, that's 5 squared, right? So I can write it down this way. And then I want to see if this middle term is equal to some 2 times something, right? In this case, it would be 2 times a 5x. right? And I want to see, does 5x, is that the product of x and 5? Yes, it is. And so that tells me this does fit the form. So I can simplify this now, or factor this into some x plus 5 squared. Okay, this is because it must follow this formula. I'm looking to see if this is a 2 times a times b. And here a is x and b is 5, at least according to that formula. So does this equal x plus 5, or 2 times x plus 5? It does, right? And so that's why this formula is going to work. Going to try and rewrite the next example the same way, right? So is this a perfect square here, this 4x squared? Yes, it is. This is 2x quantity squared. I guess this will be a minus. And the last term, 9, well, that's the same as 3 squared, right? So if I factor a 2 out of this, what do I get? I get a minus 2 times a 6x. And 6x, does that equal 2x times 3? Yes, it does. So this fits the form, okay? So this will be some 2x minus 3 quantity squared. That's what I'm going to get here for these two factored forms, okay? Let's try 2 more, see how those go. Okay, again, same thing here. I want to see, are these 2 numbers perfect squares? They are. Okay, so that's a good start. So let's write this down as some 3x quantity squared. And here we're going to have some 4 squared, right? And then we have this 24. If I factor out a 2, I'm going to get a 2 times 12x. And is 12x the product of 3x and 4? Yes, it is. Okay, so we're going to then be able to factor this into a 3x plus 4 quantity squared, just like that. And now let's do the last one. Same thing. X squared, that's a perfect square. 49, that's a perfect square. Okay, good start. X squared, here I'll say this is a 7 squared. And finally, we have to factor a 2 out. Okay, so minus 2 times 7x. Is this 7x the product of x and 7? Yes, it is. And so this must equal then x minus 7 squared. Okay, that's how we can do this, right? The sign in this middle is just going to depend on the sign of this second term in the quadratic. Okay, so there we go. This is perfect square trinomials. It's a handy formula to have on you. If you can recognize that the first and last term here are both perfect squares, then check to see if you can sort of divide this by 2, and if the result from that is a multiple of those 2 numbers there. If it is, then you can just skip right to that perfect square answer for your factorization. If you don't recognize it, don't make that a big deal. Just go the normal way of how you would solve a quadratic expression. That'll work as well. Okay, come back next time. We're going to look at yet another special factoring formula for quadratic expressions. I'll see you there.